Okay, in this video, we're going to be doing Calc AB Problem Set 65. The problems and a playlist are in the description below, and let's do this. So first up, we want to find the point or points on the curve x squared plus 4y equals 0, closest to the point 0, negative 1/4. Okay, so like, if you just think about this, you can kind of work out the answer. I don't know if I messed up when I wrote the problem, but whatever, we're going to do the math behind it, see how it goes. I think you could get this answer literally by just drawing a picture and being like, it has to be this point. But anyway, let's do it. So first thing I'm going to do is I'm going to solve for y so that I can get y as a function of x, which means every ordered pair on that thing is of the form x comma negative x squared over 4, which is not the best thing to work with, but we're going to do it anyway. All right, so now what I want to do is I want to write down the distance formula. So one point in the distance formula is x negative x squared over 4. The other point I'm going to use is 0, negative 1/4. So 0, negative 1/4 is not on the curve, because if it was on the curve, then it would be a point on the curve and it would be the closest point. So it's not on it, but I want the distance between them. So I'm going to use the good old-fashioned distance formula. That's just x2 minus x1 squared plus y2 minus y1 squared, and then square root the whole thing. So that's going to look like this. And I'm going to try to minimize this. So to minimize a function, I want to find the derivative, set the derivative equal to 0, and try to solve. So here goes the derivative. So it's going to be 1/2 the thing to the negative 1/2 times the derivative of the thing. So for the derivative of the thing, the derivative of x squared is 2x. The derivative of the next part, I'm going to chain rule. So it's going to be 2 times the thing times the derivative of that thing, which is negative 2x over 4, or negative x over 2, or negative 1/2 x. So that's our derivative. It's just an ugly chain rule, but whatever, you got to do it. So we want to take this thing, set it equal to 0. When we do that, something really nice happens, right? So that 1/2, I'm going to multiply both sides by 2. That 1/2 is gone. There's also this thing to the negative 1/2. I'm going to multiply both sides by that, and that's going to disappear. So both of these are going to disappear, and all that I'm going to be left with is this other stuff in that final set of parentheses there. So I'm going to kind of simplify it, so 2x, and then I'm going to clean this up. So we have 2 and negative x over 2, so that's going to give me just negative x, and then I'll just write the quantity negative x squared over 4 plus 1/4. I have to set this equal to 0 and try to solve it. Seems like it's going to be really hard, except it kind of isn't. Like, it's not great, but if we distribute this, we'll get x cubed over 4 minus 1/4 x equals 0, and then if we collect like terms, we'll end up with x cubed over 4 and then 8x over 4 minus 1/4, 1x over 4, which is 7x over 4. So we just get x cubed plus 7x all over 4, which equals 0, which means you can multiply both sides by 4. That 4 is gone, and then factor x cubed plus 7x to get x times the quantity x squared plus 7x. 7, not 7x. So x times the quantity x squared plus 7 equals 0. All right, we have to set this equal to 0, which means that either x is equal to 0 or x squared plus 7 equals 0, but x squared plus 7 does not equal 0. So the only thing we get out of this is x equals 0. If x is 0 and y is equal to negative x squared over 4, we get the point 0, 0, which is the vertex, which if you think about where this other point is, 0, negative 1/4, I think it's pretty obvious that the vertex is going to be the closest point, but like, whatever. That's how I did the problem. All right, so the next thing we need to do is like justify that this is a minimum. So if you think about it, the denominator part, like if you plug x equals 0 in there, you get like 0 squared is 0, so the x squared goes away, the negative x squared over 4 goes away. You just have 1/2 squared and then 1/4 squared and then the square root of that. That's positive. That's all we really care about that. Well, actually, I'm sorry. I'm not really plugging 0 in. What I meant to say is that you're squaring and you're squaring and you're adding and then you're square rooting. The denominator is positive no matter what you do. That's what I meant to say. So then I just need to figure out if the other part, like this part, if this is positive or changing from negative to positive or positive to negative. I'm doing a great job of explaining this, so you're lucky you're here. But that simplified, we saw down to this, to just basically x cubed plus 7x over 4, and if x is negative, that's definitely negative. If x is positive, that's definitely positive. So s prime definitely changes from negative to positive at x equals 0, so fs, rather, has a relative minimum. X equals 0 is the only critical point, which means that s must have an absolute minimum there. That's one of the most common ways of finding an absolute minimum. It's called the only or lonely critical point theorem. It's not actually called that, so don't write that as your justification, but we use it a lot. All right, next up. Given that f prime and g prime exist, and that f prime is greater than g prime for all x, how many times could f and g possibly intersect? I think about this, and to me it immediately sticks out that the answer is they might never intersect if f is just bigger than g. If f starts bigger than g and then increases faster or decreases less quickly, it will always stay above g. So it's possible they never intersect. But what if f starts out below g? If f starts below g, then they're definitely going to intersect. Now, I would be okay with just using that as my logic and saying, like, at most they intersect once, because once they intersect, g can never catch up again, so f will just keep going forever without ever intersecting again. So at most, the answer is 1. Here's my approach that, like, is sort of a little better, maybe, I don't know. I said h of x is f of x minus g of x. The reason I did that is because I want to talk about h prime. So h is the vertical distance between them. H prime is f prime minus g prime. We know because f prime is bigger than g prime, f prime minus g prime is always going to be greater than 0. So that means that the rate of change of the distance between them, the vertical distance between them, is always increasing. That's not true. We know the distance between them is always increasing. But the distance might be negative if f is below g. So since h is always increasing and f and g can, I'll say f and g can intersect at most once. I don't know, this is not a perfect answer. It's not like a proof. And the only way they could intersect is if f is less than g to kind of start with in your frame of mind. Easiest thing to do is just think of examples. So like e to the x versus e to the 2x minus 1. E to the 2x minus 1 is definitely growing faster than e to the x, but it starts out below it because it has a horizontal asymptote at -1. E to the x has a horizontal asymptote at 0. As you go to negative infinity, the graphs kind of look like this. So you can see like they'll intersect once, but at most once. They could never intersect again. All right, next problem. It's going to be tough getting this in under 10 minutes. Find the x-coordinates of the points of inflection of y equals 6x to the 5th minus 3x to the 4th. All right, we need the second derivative. There's no shortcut. We got to find the first derivative, which is all power rule. So y prime is 30x to the 4th minus 12x cubed. Second derivative is going to be 120x cubed minus 36x squared. We need to factor that so we can do a sign chart. So 12x squared comes out. We got 10x minus 3. Then we do our sign chart. 0, 3/10. Plug in negative a billion. You get a positive times a negative, which is negative. 0 is from a second degree term. That's even, so no sign change. 3/10 comes from a first degree term, so sign change. The only place the second derivative changes sign is at 3/10, which means that is our only point of inflection. Don't get fooled. It's not the zeros of the second derivative. It's the sign changes of the second derivative. The second derivative doesn't even need to exist, right? It's got to have a sign change. Doesn't need to exist. All right, next problem. Given cosine of x equals e to the 2y, find dy dx in terms of x. So this is interesting. Somehow the y is going to disappear. We'll see. First thing we got to do is take the derivative of both sides with respect to x. So the derivative of cosine is definitely negative sign. The derivative of e to the 2y is going to be 2e to the 2y times dy dx. So we have that. Now I'm going to solve for dy dx, which gives me negative sine of x over 2e to the 2y, which, like, if I was allowed to write my answer in terms of x and y, which frequently you are allowed with derivatives, I would be done. But here it says in terms of x. Or maybe if it didn't say in terms of x, but it was multiple choice, and none of the options had a y in it, you'd have to think to yourself, there's got to be something I can do. But it turns out e to the 2y is given as cosine of x. So I'm going to make that substitution. So negative sine of x over 2 cosine of x. That could potentially be done, but I think that sine over cosine should stand out to you as being tangent. So I'm going to write my answer as dy dx is negative 1/2 tan of x. And that's the problem set. I kind of stumbled my way through at least one of the explanations, maybe two. Sorry about that. But anyway, I hope this was helpful, and good luck.